Welcome to the ARCA Trusted OS container orchestration demo, where we're demonstrating how to deploy an application from the cloud and retrieve data from an IoT device via containerized application. We are currently on the Kubernetes cluster. You can see that the ARCA embedded node has already joined the cluster. Please note that all configurations have been done prior to this demonstration. We have the Kube Edge master, an ARCA Trusted OS Kubernetes master, and ARCA Edge, which is running ARCA Embedded. ARCA Embedded has been tagged as an edge node, so it should be understood that these are the Kubernetes cluster's nodes. Now we're on the edge device, running ARCA Embedded. We can see that Docker, used as the container engine, currently has a container running. This Docker container is in fact a container used to implement Kube Edge's mechanics. This container is running permanently on the edge device. However, when we look from the master node using kubectl, we see that there is currently no pod running in the Kubernetes cluster. We're now going to use the deployment file, which allows us to deploy the application needed to communicate with the medical device. We just have to run the kubectl command to deploy it. Let's wait a few seconds until the application is deployed on the edge device. And when we look at the running pods in the Kubernetes cluster, we can now see that there is a pod running. Also, if we look at which Docker containers are running, we can see that an additional container to our application has been created for the Kube Edge mechanics. In fact, this container is needed to run the pod. It is the one responsible for the communication between the Docker container and the Kubernetes cluster. We're now going to display the container logs in order to see what's going on inside. Specifically, the container will simply establish a TLS session with the biomedical device. We can now see that the container is waiting for a connection to be established. We are now on the interface which is used to program the biomedical device, the secure element in this case. We're simply executing the C code that creates the TLS session with the edge device through a low-energy Bluetooth link. The last component that is launched is the untrusted bridge. The role of this bridge is to receive the Bluetooth packets and forward them to our edge device via TCP. This bridge might be needed in certain use cases where a single edge device needs to establish BLE connections with devices in different locations. Thanks to the TLS session, this bridge cannot compromise the confidentiality of the communication between the biomedical device and the edge device. Back inside the pod, we can see that the TLS handshake is taking place between the biomedical device and our container. Once the session is established, we can visualize data arriving regularly from the biomedical device. For the purpose of the demo, the biomedical device simply takes its serial number, encrypts it, and sends it in a loop to our edge device. Therefore, we see how to deploy an application from the cloud and retrieve data from this IoT device via containerized application.